For this next part, we're going to focus on 30, 45, and 60 degree angles. Sine, cosine, we got those from the unit circle, but just a refresher. The sine is the y value in the unit circle. So the sine of 30 degrees, or the sine of pi over 6, if we go to the unit circle, it's the y value. It's right there. It's 1/2. The sine of 45 degrees is the square root of 2 over 2. And the sine of 60 degrees, I was thinking a little bit ahead, is the square root of 3 over 2. The cosine of 30 degrees is the square root of 3 over 2, coincidentally. Well, not coincidence at all. It's the same value as the sine of 60 degrees. The cosine of 45 degrees is also square root of 2 over 2, the same as the sine of 45 degrees. The cosine of 60 degrees is the same as the sine of 30 degrees, 1/2. Now, we did a little bit of tangents in the previous section in 4.2, but just a refresher, the tangents of an angle are the y value over the x value, in other words, the sine over the cosine. So the tangent of 30 degrees would be 1/2 over the square root of 3 over 2. And after you go through and simplify all that using using multiplying by the reciprocal, rationalizing the denominator, you end up with the square root of 3 over 3. Now for 45 degrees, you'll take the sine over the cosine, so you take root 2 over 2 divided by root 2 over 2. That seems complicated, but it's the same fraction divided by itself. It just simplifies down to 1. Now for tangent, it's going to be the root 3 over 2 divided by 1/2. After you go through the process of simplifying that down, you just end up with the square root of 3. So those are going to be some helpful values that we're going to use throughout this unit. So to finish up this section, we're going to figure out how to find the trig functions given one trig function. So let theta be an acute angle such that sine of theta equals 0.6, and we're asked to find cosine and tangent of that angle as well. So the sine of whatever our mystery angle is 0.6. Now I'm going to draw a triangle here. On that triangle, let me draw my straight line tool here. Now, it really doesn't matter what you label as what, as long as you have one angle that's a right angle. I usually just go theta down here. Now, just a refresher, the sine is always your opposite over your hypotenuse. Well, 0.6 is not the most helpful. So, thinking about 0.6 as a fraction, 0.6, we often kind of gloss over that. That's 6/10. So we can say it is 6 over 10, which if we reduce, we can make it 3 over 5. Now, as we said earlier, the sine is the opposite side divided by the hypotenuse. So even though we don't know the exact lengths of this triangle, we can label things. The opposite side of that angle is 3, the hypotenuse is 5. Even if those aren't the actual measures, the relationship between those two, it could be 6 and 10, it could be 3 and 5, it could be 9 and 15, the proportion is always going to be that same thing. Now, based on what we know about good old Pythagorean theorem, a squared plus b squared equals c squared, I'm going to call the adjacent side here A, the opposite leg B, and the hypotenuse C. We're going to have, we don't know what A is yet. We got a squared plus, well, 3 squared equals 5 squared. Folks, we actually did a problem like this on the last section of notes. And you might already know this is the Pythagorean triple. Pythagorean triples, you get nice convenient integers for all three sides. But I'm going to keep going through this. We got a squared plus 9 equals 25. There we go. Subtract 9 from both sides, we get a squared equals 16. To solve for a, we're going to take the square root of both sides, and we end up with a equals, and since we're only talking distance, we're just going to focus on the positive, so a is 4. So now we're asked to find the cosine of whatever our angle is and the tangent of whatever our angle is. The cosine, remember cosine is adjacent of our hypotenuse. The adjacent leg is 4, hypotenuse is 5. Tangent is the opposite side, 3, over the adjacent side, 4. So even though we didn't know the exact measures of anything, we only knew the relative sine of theta equals 0.6, which we converted to a fraction, which we made some proportions out of that, we were still able to find cosine and tangent.